All right, let's jump right in. You know, we're surrounded by this invisible soup of energy, right? Wi-Fi signals, cell signals, radio waves, they're literally everywhere. But what if, and this is the big question, what if those signals could do more than just carry our data? What if they could actually power our devices? I mean, really, what if we could just pull energy right out of thin air?
Just think about it for a second. Imagine your fitness tracker or your smartwatch. What if it just never needed charging, ever? No more waking up to a dead battery, no more hunting for that specific charging cable, just no more hassle. And look, this isn't some far-off sci-fi dream. This is the very real promise of a technology that could completely change how we interact with all the little gadgets that are, let's be honest, a huge part of our lives now.
So to really get why this is such a potential game changer, we have to talk about the thing that holds everything back. It's the unsung, and let's be real, super frustrating hero of our connected world, the battery. You see, for every amazing wireless gadget we come up with, there's a battery that ties it right back to a wall socket. And that right there is a huge bottleneck.
And yeah, the problems with batteries, we all know them. We feel them every day. They only last so long, right? Most of them can only handle about 1,000 charges before they start to die. They're a nightmare for the environment when we throw them out. The constant recharging is, well, it's just a pain. But maybe the biggest thing is they're bulky. They literally dictate how big and heavy our gadgets have to be, which holds back how small and, invisible our tech can get.
And this whole battery problem, it's not just about convenience. In some cases, it's literally a matter of life and death. Get this, 17.5 million people die from cardiovascular diseases every single year. Now, continuous heart monitors could be a lifesaver for so many of them, but they're limited by that same old problem. They always need a recharge.
Okay, but what if the solution has been staring us in the face this whole time? What if it's literally all around us? Instead of trying to cram bigger batteries into our devices, what if we could just harvest power directly from the air? Yeah, we're talking about tapping into a totally invisible power source that's already everywhere in our modern world.
The tech that makes all this possible has a name. It's called radio frequency energy harvesting, or just RF energy harvesting, and it's exactly what it sounds like. It's the process of capturing those background electromagnetic waves, from your Wi-Fi router, from cell towers, even from old-school TV broadcasts, and turning them into actual usable electricity for small, low-power gadgets. So, how in the world do you actually turn an invisible Wi-Fi signal into electricity? Well, the process is actually pretty straightforward. It basically breaks down into 4 key steps. Okay, so first, you've got an antenna. Think of it like a net, just scooping up all those invisible radio waves floating around. Step 2, that energy goes to a special circuit called a rectifier. This thing is basically a one-way street for electricity, and it converts the waves into the DC power our electronics actually need. Then, you have a power management circuit that acts like a tiny traffic cop, making sure the energy goes where it needs to, super efficiently. And finally, that little bit of power gets stored up, usually in a supercapacitor, ready to go when the device needs it. Now you're probably thinking, wait, don't we already have solar power for this? And that's a great point, but here's the difference. Solar is awesome if you're in the sun. Harvesting energy from vibrations is also cool, but you need movement. The big advantage of RF energy is that it's always on. It's predictable, it's consistent in any city or home, and crucially, it works indoors where solar and other sources just can't.
Okay, let's be real for a second. We have to manage expectations here. The amount of power you can get from RF is tiny. It's a tiny fraction of what you get from direct sunlight. We're talking microwatts. So the key takeaway is this. We're not talking about charging your phone or your laptop with this stuff, not even close. This is all about powering the next generation of super low power sensors, devices that just need to sip a little bit of energy, not gulp it down.
And that brings us to what might be the most exciting place this tech could be used, healthcare. Because in medicine, that small, constant trickle of power could be absolutely revolutionary. It could literally make charging medical wearables a thing of the past.
Just think about a hospital environment for a minute. There was a study in 2023 that found stethoscopes can get just as contaminated as unwashed hands, which can spread infections. Now imagine a sensor that doesn't need to be handled. A self-powered sensor is a total game changer here. It can give doctors vital signs without ever being touched or recharged or constantly re-sterilized.
And listen, this isn't just an idea on a whiteboard. People are actually building this stuff. Here are 2 examples of real prototypes.
One is a little sensor for your finger that's designed to spot an irregular heartbeat, or arrhythmia. The other is an ear clip for more general monitoring. But here's the coolest part. Both of them are completely self-powered, and both can automatically send out an alert to get medical help.
And just look at the accuracy on these things. The arrhythmia detector, it hit 97.5% accuracy. That's incredible. That's not just a cool science project anymore. That's medical-grade reliability. And it's all being powered by nothing but the air around it. So when you pull all of this together, you can start to see the beginning of something really big. We're talking about a smartwear revolution. It's a future where our tech isn't just something we wear, but something that's totally integrated, practically invisible, and completely self-sustaining.
Really, the holy grail here, the ultimate goal of all this research, is to create something like a patch. A thin, flexible patch that's safe for your skin, that you can just put on and completely forget about. A patch that powers itself from the Wi-Fi in the room and just quietly sends out valuable health data 24/7 with zero charging required.
So here's how you'd actually build one of these patches. You'd start with a flexible material that's safe for skiing. Then you'd literally print an antenna right onto it to catch Wi-Fi and 5G signals. That energy then flows to the rectifier circuit we talked about, which turns it into power. And that little bit of power runs the whole show. It powers a tiny computer chip, the brains of the operation, and of course the actual health sensors. To get the data out, it uses a super low energy signal, like Bluetooth low energy. The whole thing is a complete self-powering system on a tiny flexible patch.
And you know, the potential here goes way beyond just healthcare. Think about it. Sports jerseys that track an athlete's vitals during a game, tiny environmental sensors all over a smart city, all powered by the city's own RF grid, battery-free communication patches for soldiers, self-powered sensors on remote machinery in a factory. You can even power tiny satellites in space by beaming energy up from Earth. I mean, the possibilities are just endless.
Which really brings us to one last big question. Once we finally break free from the tyranny of the battery, once our technology becomes so seamless and invisible that it just powers itself, what new things will we even be able to imagine? What will we create next?